Hello everyone. In this particular lecture, I will discuss with you the most important data structures, and that is queue. So in computer science, the data structures are ways to store and organize data so it can be used efficiently. Actually, knowing about data structure is important because picking the right one can dramatically affect the performance of a program. So in this particular lecture, we will see what is the major task of queue and what we can do with the help of queue data structures. So now look at the queue. The word queue is not used in American English very often, but in British English it means a single file line. So let's think about line at a movie theater. So somebody start the line and additional people may join after the first person, and the first person to get help will be the first person who joined the line, and so on. So queues have a front and a back. As you can see here, this is the front and this is the back, and we can add elements to a queue only from back, and we can remove element only from the queue with the help of front. In computer science, we might talk about adding as in queuing, that's mean queue, and removing as dequeuing, that's mean dequeue, just like in a stack. Again, I'm repeating. In programming term, pushing an item in the queue is called an in queue. Here it's mentioned. And removing an item from the queue, that's mean dequeue. That's mean we can add element only from the back. This is the back, and we can delete or remove element only from the front, and this is the front. And we might talk about adding as in queuing, and deleting or removing element as in dequeuing, means dequeue operations. And in the programming term, putting an item in the queue is called an in queue, and removing an item from the queue is called dequeue. So queue don't have indexes, so we don't access them directly. Again, think about the movie theater line example. The person working at the theater can't just ask the person in the red shirt to come and we help the patrons get help in order. So a queue is the data structure in which just like stack elements are sorted by insertion order. However, in queues, the first element that you put in the first one that comes out again element have no indexes. So we can't access an element in the middle of a queue. We can only add to the back and remove from the front. Queues are useful in context when we are managing resources. For example, think of a printer queue. If we have many people in the office sending jobs to the same printer, the first person who sends a job to the printer gets their job first. Similarly, if we have a website and several pupils are accessing that website, the first person who tries to access it is the first person who gets the page back. Another good example of a queue is any queue of consumer for a resources where the customer that come first is come first. It is similar to the ticket queuing. For example, ticket queue inside a cinema hall where the first person entering the queue is the first person who gets the ticket. Here you can see the different lines. Queue elements are sorted by insertion order in the queue. We can say queue is first element in first out. That's mean first in first serve. Yeah, we can say first in first out. Elements have no indexes, can only add to the back and remove from the front. Here are some components of queue: front, rear, element, and then the max queue. Front is a variable which refers to the first position in a queue. Rear is a variable which refers to the last position in the queue. And element is a component which has data. And the max queue is variable that describe the numbers of element in a queue. maximum number of elements in a queue. Here you can see the further demonstration of queue. Queue is linear data structure. It follows first in first served principle. It has two pointers. The first one is the rear and the second one is the front. So this is very simple example. In the above image you can see, since one was kept in the queue before two, it was the first to be removed from the queue as well. It follows the Fifo rules. Thank you.